So for cos 3x, you have to use the double angle formula and the compound formula. So if you look carefully, let's see if I can make this big enough. Cos 3x is also cos 2x plus x. Now, if we look at the division of the compound formula, we discover, I just want you to remember that cos 3x is this. We discover that's the same as cos angle A plus cos angle B. So we look at this formula right here, and we pull it down. This again. There we go. And instead of A and B, we replace it with 2x and x. Times cos of 2x minus sine of x times sine of 2x. It's at this point that we see we have a double angle formula in there. So wherever we see the double angle, we're going to put it in brackets. And we're going to replace it with what the double angle is equivalent to. Make a little bit. I'm going to get rid of everything as we go. And so then we move over here, and we've got to grab the two double angle formulas. Now, wherever I see cos 2x, I'll make it a little smaller again. This time I'm just going to widen it. So whenever I see sine 2x, and replace it with what sine 2x is equivalent to. And wherever I see cos 2x, I'm going to replace it with whatever cos 2x is equivalent to. Now, this is true for all math. You can always replace. Just remember that in between here, they're not multiplying, but rather subtracting. It's easy to lose track of your signs. Also remember, and here's another thing, this is something students have a tough time with. What is that minus, really? Well, that minus is a minus 1 times all these things. So when it comes time to straighten things out, I can multiply this minus 1 times everything in there. Something hard that students have difficulty with unless you break it down like this. Like 10 minus 3 is clearly 7, right? But 3 can be replaced with 2 plus 1. If I just use that minus for the 2, not the 1, I'd get the wrong answer. 10 minus 2 plus 1, 9. Well, that's not right. But really, that minus 1 is multiplying whatever I turn that bracket into. And it becomes minus 2, distributes through, and minus 1. And then it's correct. 10 minus 2 minus 1 is 7, just the way 10 minus 3 is 7. So before I do that, though, I'm going to distribute it. Here I have cos x times cos x squared, which is cos x cubed, times minus sine squared, which becomes cos x minus cos x times sine squared x. So it means this one becomes a cubed, and this one over here stays a square. And then over here, I'm going to multiply the brackets before I multiply the minus through. And I get 2 sine cubed x. And this time, oh yeah, 2 sine. Make sure that the sine 2x was replaced correctly. Yeah, it was. And you know what? The other thing you should do is always replace your sine, your cos 2x with something that's going to work for you for the other ones. because cos cubed, you can see, might cause some difficulties. So instead, I think what I'm going to do over here, because I have so many choices, is I'm actually going to use this one. Because as you can see, if I use the other one, I get a cos cubed. And maybe that's not in my best interest. So instead, I'm going to use that one. So this one, I just get a cos x, which is nice. And then times the -2, it becomes -2. And I'm going to write it, yeah, cos x sine x squared. And then we have that minus. So I'm going to write it like that. Might prove useful, we'll see. And always go back and replace it. Anyway, to continue this, I've got 2 sine squared x. And because this is all multiplication, oh yeah, because these things are always already multiplied, you just multiply the first one. It's not these aren't added like the one on the left was, so it's just like that. So that minus can just stay the way it is. There's no distribution. So we're at this stage. Now, the secret here is this thing minus this thing, which is sine squared, I believe. Yeah, minus 2 sine squared this thing. So you can rearrange anything that's multiplying to understand it better. This thing, minus 2 sine squared, is the same as this thing, minus 2 cos sine squared. So really, it's -4. So that's all you are left with, cos -4 cos sine x squared. Now you could factor out the cos. I'm not sure why you would. Now for full marks, because your teacher probably wants you to be able to do it twice, remember that we replaced this one. So this is one identity, by the way. Cos 3x is equal to this. Cos x -4 times cos sine squared. There we go. There's that one. Then there's this one. Remember that we replaced this all with, I probably should have kept it, cos 2x plus x. And we ended up with cos 2x times cos x minus sine x times, sine x 2x times sine x. Now remember, we replaced the cos 2x with one that we wanted, but you could replace it with 2 possible others up here. So that means there's 2 other ways to come up with our solution. We use this one. Now let's go and use this one. This is what cos 2x could be replaced with. Okay. And sine 2x, you're going to use this each time. Sine 2x is replaced with this each time. But cos 2x has 2 different options. So we're going to forget, again, what we're looking for here. Go here. And the point is, over here in this bracket, I can replace it with this second thing. That means there's more than one identity. And it's going to be multiplying this. And again, when something's subtracting, you have to put it in brackets because you're going to distribute it. And then this one, I'm always going to, so the second one, I'm always going to end up with this here. So this second part, because it's always going to be this times this, this second part is always going to be -2 sine x squared times cos x. But keep in mind that sine x squared can be turned into something else as well. So we're going to just leave that left side here like that. Just put these other options. Right now we're using this one and this one. There we go. So this one, when I expand it, I get cos cubed. This one's going to probably be the most useless one. Minus a sine squared cos. Sine squared x times cos x. And this one's just going to be the same. Unless we use the proper way that I've been doing it, like that. So this one's going to be cos cubed minus sine squared times cos x minus 2 sine squared times cos x. So this one, if we wanted it all in cos, okay, well, let's notice that they're both the same thing again. So it's really 1 apple minus 2 apples minus 3. Oh, no, it's just minus 1. That's minus 1. How did I get that 2 in there? Oh, the 2's over here. Okay, so minus 3. So this time there's 3 apples. Now notice that if I wanted to, and same with the last one, I could convert everything to cos, because sine squared is 1 minus cos squared x. That's what sine squared is equal to. So it's likely that your teacher wants it converted all to cos squared. That means this little part here can be replaced with this part here. So minus 3 times that times cos. So if I do minus 3 times that, I get minus 3 plus 3 cos squared times cos. What's cos squared times cos? Let's take care of these two first. Cos cubed. So I get minus 3 plus 3. This is another version of this one. Try to remember that this becomes cos cubed because that's second cos. Well, actually, let's do it properly because, yeah. Before I replace that, this is squared here because it's replacing the sign. Before I multiply it by that 3, I'm going to multiply it by the cos x. I'm going to distribute it through and just leave that 3. And actually, you know what? Let's go back even further and do it back here, just so it's less confusing. Let's assume that your teacher wanted it all in cos. So before I take care of these things here and expand these things, let's replace this sine squared with 1 minus cos. So it becomes 2 minus cos squared. That's all going to be multiplying cos. So it becomes minus 2 oh yeah, and it becomes positive. So it becomes minus 2 times 1 minus cos squared. So it's going to be plus, and all in brackets. Yeah, it just makes it harder, doesn't it? Let's leave that 2 out front and multiply the cos x times the 1 minus cos squared. So instead, I'm multiplying the 2 through. I'm going to replace the sine squared here. I'm going to put the cos up here, put the sine squared last, and replace it with 1 minus sine squared, which is what 1 minus cos squared, rather, which is what sine squared is. And I'm going to multiply 2 cos x times 1 and 2 cos x times that. And it becomes, and minus 2 times that. So it becomes minus 2 cos x times that one. And then minus, and then become plus, because it's times the minus cos squared, 2 cos cubed. So there we go. That's what this second one expands to. It now is expanded, so it does have 2 separate brackets. Cubed. And this first one, when we expand it, becomes cos cubed. Again. Cubed. Minus sine squared, or cos x times sine squared. But remember, sine squared can be replaced with this. So you get cos, this is cos x cubed, minus cos x plus cos cubed. Because it was cos squared there, not cos 2x. All tough to keep track of, but this is if we wanted to come up with this. So that means this can be expanded to this. We get minus 2 cos x plus 2 cos squared. So remember, we've got a bunch of cos cubes in here. 1 cos cubed plus cos cubed plus 2 cos cubed is 4 cos cubed. And I'm going to check the math on that because I think it should be 3 cos cubed x. And then minus cos x minus 2 cos x minus 3 cos x. I think I might have did a math mistake there, and it should be a 3. I think it should be 3 cos 3x minus, or sorry, 3 cos cubed x minus 3 cos x. So I have to go back and check all my math. But you can see this is what you do. You replace it. If you want me to do them all, I can. I probably should because that was a cluster F, but I want to move on. How do they come up with the double angle formula? How do they come up with the double angle formula? Well, cos of 2x, let's do sine. Sine of 2x is the same as sine of x plus x. So what they did is they used the additional formula, sine A times cos B plus cos A sine B. But in this case, the angles weren't different. They were just this. And of course, if you rearrange the second one, because anything multiplied can be rearranged, it's just this. I'm going to leave it in bold. And so that's 2 sine x cos x. Well, that's the double angle formula for sine 2x. For cos A plus B, the reason they came up with several of them is because there's a sine squared in there. But again, instead of using 2 different angles, they use the same angle. Which means that's the same as cos x times cos x minus sine x times sine x. And that's the same as cos x squared minus sine x squared, like that. And that's the first double angle you have for cos right there. And I think I already taught you that all they do is replace this with 1 minus cos squared or this with 1 minus sine squared to come up with the other two. So this, replacing it with cos squared, sine squared with cos 1 minus cos squared, I get cos squared x minus, open brackets, because when you're replacing things with a subtraction, you have to create a whole bracket like I taught you with 10 minus 7 squared. When I distribute that, that becomes cos squared. Sorry, I got to distribute the minus first. Becomes not cos squared, that's not cos 2x, cos squared x minus 1 plus cos squared. And so that becomes 2 cos squared x minus 1. Like that. Well, that's this identity here. The second one. And the third one, instead of replacing the sine squared, they just replaced it with the cos squared. And they replaced the cos squared with 1 minus sine squared. And it became minus sine squared, which just becomes 1 minus 2 sine squared. And that's the second identity right here. So that's how they did all the cos squareds. The tan's no different. But of course, everybody hates the tan addition formula. So it's the same thing, except this time it's not a plus b, but x plus x. So each thing is the same angle. So everywhere I see a and b, just replace it with x. The same angle, in other words. Could all be replaced with A, and it could all be replaced with B. Just a way of saying we're multiplying the same angle. So up here, tan x plus tan x is 2 tan x. And down here, 1 minus tan x times tan x is tan squared x. And that's the double angle formula. And that's how they came up with it. Right here, see? And there you go. That's how they came up with the double. If you need me to walk you through the distribution of the other one, I will. I just don't have time at the moment.